Hi guys, welcome back to the channel. And as always, as some housekeeping things to start off with, this video has been sponsored by DASYLab. They did provide me with a license to the software you're about to see, as well as all thoughts and expressions and opinions portrayed in this video are my own and do not reflect those of any company I am currently or have previously been associated with. So, roll the intro. So in my previous video, I went in depth on how I create a benchtop setup for a target device to test it remotely and create an automated test sequence to run in one fell swoop versus constant button presses. In that video, I used a new to me software platform called DASYLab. And while I showed how I created that program, I didn't really get into the nitty-gritty how-tos of DASYLab itself, which I think warrants another video. I also didn't want that video to be an hour long because we all know how I can ramble. Without further ado, let's get into this tutorial for DASYLab specifically, starting with the installation. So for the installation, I do already have it installed, and considering most other installation tutorial videos or any videos that include an installation, it's just fast forwarding through loader screens. I'm gonna skip that and just talk through the steps of what to install. Most of it are GUIs, you just like installer GUIs you just launch and they do their own thing anyway. It's really just the sequence you need to know. So leave me feedback if that's sufficient for this. Otherwise, I'll do it different next time. So DASYLab, because it has the option to talk to different types of instruments, it's not constrained to one particular set. There is some prep that's necessary to install the drivers or software for your instruments themselves first, so for DASYLab to piggyback off of or call in the background. The first of which is, since I am using my analog discovery USB oscilloscopes, I do need to install waveforms first. So that's what I have. My installer still here in the downloads folder. So make sure you've got waveforms installed first and running such that it can connect to all of your devices, because the waveforms SDK is how the actual blocks in DASYLab will communicate to your devices. The second thing you'll need is Instacal. That's a generalized driver that DASYLab requires. I talk to a lot of my other devices via its network connection using Skippy commands, explained in the other video. So waveforms and Instacal are the only two things that I need specifically pre-installed before I install DASYLab. If you're using something like the MCC measurement devices, or if you're using some other NI instrument, you might need to install an NI driver underneath. I was using some other stuff that uses the NI CAN driver, so that's why I have the NI CAN 1500 driver here. So that's all the pre-installation you need to do. The next thing you'll do is, when you download the DASYLab package, the first thing is you'll have an installer. So in the installer directory, run this install GUI. That will run through everything, and once it actually installs DASYLab, you'll come back and run this DASYLab setup GUI, which will ultimately launch this DASYLab configurator, but also, even though it automatically launches it when it's done installing, you can always come back to reconfigure this. That's what this configurator program is, and this lets you enable the actual extra drivers you want. So even though I had DASYLab pre-installed anyway, I still have to come in and enable it. Which, for DASYLab specifically, there's also this package to add the hooks in the configurator for it. The DASYLab packages in DASYLab are currently still in their beta form, so that's why this Digilant enable file is required. So if you run this to launch the DASYLab configurator from, that's what actually adds the hooks to recognize waveform is there. I don't know if that will be a forever requirement. DASYLab is a Digilant product now, if I understand correctly, so I assume this to progress and just become a permanent installment. So maybe the Digilant tab will move up into the data acquisition tab here, but you can see here, these are all the possible drivers you can add or enable. Obviously, it's just like with anything else, the more drivers you enable, the more space on your hard drive that's going to take up. I don't think any of these drivers consume too much space, unlike Vivado and Vitis and all of that. So you can be a little bit more liberal in the amount of drivers you enable. But that covers the installation of it. There are quite a few manuals for DASYLab that do give you screenshots to walk through those, specifically if you need help. Another note that I found, right now, DASYLab, the latest version of Windows it supports is Windows 10. Luckily, I've just been too lazy to update my Windows VM from 10 to 11. That's another thing I expect to change. Digilant seems to be revamping everything and re-updating things, so I do expect a lot of updates to come soon. But one other quick note that I found is a quirk. If the installer gives you any sort of error about the lab in the program's x86 file not existing, just make sure you manually rename it to DASYLab 2024_enable. Again, I expect this to just be a glitch with the current latest version. I don't expect this to remain in future updates as DASYLab gets updated for later versions of Windows. But just quick note, that took me a couple minutes to figure out when I was first installing. But it's a quick, easy fix. Hello, do you want to teach about DASYLab? I have a helper now. All right, so now that we've got the installation covered, let's get into the actual how-to tutorial. If you're gonna help, you can't climb on my shoulders. So the first thing to note or understand about DASYLab is there's 3 different views. Also coupled with the fact that DASYLab is kind of a 2-in-1 type of thing. If you're familiar with LabVIEW at all, LabVIEW and Test Stand, both NI products, LabVIEW actually is where you create your GUIs, create your flow graphs, block diagrams for those flow graphs, the actual programs that execute each individual tasks. They're referred to as worksheets in DASYLab. But then Test Stand is your sequencer, where you call each individual test, which is each individual LabVIEW flow graph or VI file, and it runs each of them in a certain sequence, and it stops and starts each one based on certain parameters you set in it. And Test Stand is what's called a sequencer program. The nice thing about DASYLab is DASYLab has a sequencer built into it. Your worksheet view here, which is like your regular LabVIEW block diagram, or where you actually drag and drop your blocks and connect them to create your program. You have your sequencer, which is where you can call different worksheets and set actions as to how to transition between those worksheets. Therefore, so when you run a sequencer, it runs all of your worksheets in the right order or sequence. And then the last view is called the layout view. By default, there's no layout. In a new one, you always have to create a new layout. But the layout is your GUI for the specific worksheet. So a sequence file can call multiple worksheets, and one worksheet can have a corresponding layout with it. Depending on which license you buy for DASYLab, it limits the number of layout views you can have with a worksheet. But for the most part, you're good with one layout view. That's all I've ever used. Let's switch back to our worksheet view. The worksheet view is where all the actual magic happens. One thing to note that is a little bit different about DASYLab compared to like LabVIEW or any other graphical coding software. So when I say graphical coding software where you have just visual blocks that you're dragging and dropping into some sort of diagram and you're wiring them up. So like LabVIEW, GNU Radio, if you've ever used that. Typically in those applications, you're setting like your sampling frequency in each individual block, whereas in DASYLab, that's set for the overall worksheet. You don't really control that per individual block. That was a little bit new for me to get used to, so coming in under measurement and then driver, this is where you set the overall sampling rate for your whole worksheet. So each block that you put in your worksheet will be running at the sampling rate. Block size, which is the amount of RAM that your worksheet's going to consume when it's running. If you leave the specify automatically, you're gonna give DASYLab free rein to consume as much memory as it needs to, or each individual block. Or you can limit it to a specific byte of memory at a time. Personally, I found, at least in this version of DASYLab, I found, and maybe it's just my particular installation and the fact that my Windows 10 is a little bit out of date, I do feel like I have a little bit, there's some sort of little bit of a memory leak issue somewhere, which I have found is alleviated a little bit when I specify a block size and I don't let it specify the block size automatically as it needs it. Again, that's just a quirk with this specific version of DASYLab. I do expect that to be updated in the future. So along with measurement setup, you have the time-based setup. While the measurement setup is the sampling rate at which the worksheet and all of the blocks are sampling at, the time base is the sampling rate you're setting for the target device that you're working with. So, since if I'm working with the Analog Discovery 3 or the ADP3450, if I choose a sampling rate of, say, the max 5 gigahertz here, which DASYLab can support, even though I know individually these guys can go a little bit higher. With the max sampling rate 5 gigahertz there, that means the measurement sampling rate can't be any higher than that. Realistically, for the best performance I've found, if I set the time base for my target device to be as high as possible, and then I'll run my worksheets at about half of that, gives me the best fidelity in my data. Kind of the main idea of worksheet creation. There's 4 main steps in any worksheet you have. Pick your target input. So whether that is some sort of digital device, one of the MCC computing devices, you need some sort of data input, because the overall goal or functionality of DASYLab is a data acquisition program. So pick your target data, or pick your target hardware to acquire data from, determine what you need to do to process that data. So whether it's run it through a filter, check to see when it reaches a threshold, like all the various things. Process your data, condition the data, determine what you want to do after that. Do you just want to store everything to a file? Do you want to stop the measurement at some point? And then the final step is put that into, if you have multiple functions that are across multiple worksheets, put that into the sequencer. So I found that there's a really great example, a main menu example that kind of goes through and lets you see what all this looks like, kind of like a whole view of everything, the sequencer, each individual worksheet, that type of thing. So let's open that up. One thing that did kind of throw me a little bit for a loop in DASYLab is that even though your sequencer functionality and worksheet, like individual program, even though that's all built into the same software application, it's the same instance running, A sequencer file is a completely separate file, so just because you have a worksheet open doesn't necessarily mean that it's associated or in the sequence file at all. You can open worksheets from a sequence file, but that threw me off of her a little bit just because you can't have multiple instances of DASYLab open on Windows right now. So when you're switching from the worksheet to the sequencer view, they are two separate things versus the worksheet view and its corresponding display or layout, aka GUI. That is all technically the same one file, the same worksheet file. So I have the actual main menu itself, the worksheet for that. So let's open that. So by default, this is what the layout view or the GUI view for a worksheet looks like. So to switch over to the actual worksheet where all of the functionality is, you'll choose Window and Worksheet. So, like I said, those of you familiar with LabVIEW, this is your block diagram, just called the worksheet instead. You'll see this is where you can add modules like your switches, your control buttons. This is they have just a menu task in here. So in your menu, you have all the different tasks you can choose. And then an actual start-stop button, which then leads into an action module. Which, because this is a part of an overall sequence, you'll use global variables to talk between different worksheets in a sequence. Just like any other software application, you'll have global variables if different functions are calling from different source files. So, switching over to the sequencer, let's find the sequence file in this example and take a look at that. So, download. Oh, no, not download. So the sequence, it's a different file type, the sequence file. So when you open this, you'll notice we've got our main menu worksheet that we just looked at. So when you add, when you have a sequence, you'll add new worksheet. So that's how you just right click on the sequence and select new worksheet. You'll do that each time to add each of these worksheets. And then whichever worksheet you want to start the sequence with, you'll right click on it and say set start worksheet. So when you run the sequence, it knows which worksheet to start with, and then you can add each individual action here. So individual actions such as on start measurement, load or show the layout. So that'll switch to the layout view of the main menu worksheet that we just looked at. And then based upon which task I choose in that little menu selection, it will load and start the corresponding task worksheet. So this particular sequence is you have one start worksheet that gives you the choice to run 4 other worksheets. And these are pretty, because it's just a demo kind of showing you the structure of everything, they're pretty simple worksheets. So if you want to open one of your worksheets from the sequence, just right click and say load worksheet. I've noticed that worksheets, every time I open like any modules within it, it detects that as a modification even if I haven't changed anything. I'm going to hit no since this is just a demo. I don't want to change anything about it. So you'll notice that now, because I chose to load task 2, the task 2 worksheet is bold or in bold compared to everything else, which means it's loaded in the background. So if I switch to the worksheet view now, that will show me that worksheet, that task 2 worksheet. So as you can see, this is a pretty straightforward demo worksheet. It just has a signal generator plotted on a chart, shown and then being recorded and saved. And again, we have looks like a start-stop switch, which, let's look at the layout screen of this. Oh, so we've got our 3 little windows and then return to main menu. So let's take a look at the sequencer. Oh, so I didn't notice that each of these actions for each task worksheet will reload back to the main menu. So it doesn't necessarily have to be a linear sequence that has a stopping point. You can have an infinite loop like this to run until you hit the stop button up here from the sequence window. One thing I have found is make sure you hit the stop button from the sequence window if you're wanting to stop the overall sequence. Because like I said, the sequence file and the worksheet file are 2 separate things. I've found that if I have a sequence running, but I'm in the worksheet view or layout of the worksheets view and I try to hit stop there, it seems to kind of cause some chaos and DASYLab isn't sure what I actually want it to do. Whenever you want to stop the sequence, if it doesn't have a built-in stop, make sure you stop it from the sequencer view. So to get into some more in-depth examples, let's take a look at the setup that I had for my automated benchtop setup here. So looking at my specific example here, I have a worksheet that is controlling the power supply I have on my bench here. It's configuring the voltage setting for it via Skippy commands. So starting with the generalized workflow for a worksheet, the first step is to choose my input. To open up a socket and send Skippy commands, I do that with the ICOM input block. As you can see, depending on the driver you have, there's lots of you can have a straight analog input or output. Those particular blocks are used with the MCC measurement devices. And then if you install any extra drivers like NI device drivers, those will appear here as well. So like my NI CAN driver you can see is here, as well as Digilent with the AI record to talk to the analog discovery devices. So like I said, I'm just opening up a port and sending Skippy commands to my power supply. So once you can either just drag and drop from this module screen over here, or there's also this module tab up here at the top with all the same menu items, so you can just single click from here as well. Which that's an option because you can hide this little menu bar here, or say resize it, kind of move it over here and get it out of your way if you want more space in the diagram area of the worksheet. So for Skippy commands specifically, the first thing to do when you have an ICOM, first thing to do for an ICOM input block is set up the interface. So you'll want to give the host IP address. You're selecting either a TCP/IP or COM serial interface. So for this, select a TCP/IP and then provide the host IP address. Because this is for Skippy commands, that's just sending ASCII strings over a particular socket. I'm going to choose other port for transport protocol because every device just chooses a random open port for its Skippy commands to operate on to create that socket. Like I mentioned in the previous video, whatever device you're using, the user manual will tell you which port. So here in the ICOM setup, you'll choose other port because it's just a plain socket. It's not any of these other communication protocols. And then you'll just provide the IP address, that particular port number. Again, like I mentioned in that other video, I highly recommend turning DHCP off so it doesn't risk your IP address changing on your device, especially if you're not near it after you set it up. The other really cool feature is you have the ICOM monitor, so you can kind of test out your Skippy commands to make sure you have the right ones. So if you open this up, you just have a blank option here to send your Skippy commands. So I'm just going to send query its ID. So I'll send it and then I get to see just the raw input back from it. The reason this is handy is this lets me see exactly how many characters and the format of the characters in its response. That's important because I'll have to set that here on the return measurement data format. So because this particular worksheet is querying what the voltage setting is, let me just copy this over, come back to the icon monitor. I'm gonna paste it here. So when I send that, I know that I'm going to get, the format's gonna come back in 5 characters total. So I've got the first digit, the period, and then the next 3 digits. So I have 5 characters returning. So I come back here, tell it I have 5 ASCII characters coming back, followed by a new line. And that way it knows how to tell the next block, my next display block, what the data looks like and how the next display block needs to format it. Under options in the ICOM interface, there's 3 commands you can set. There's a reset command, a start command, and a stop command. What's important to know about the start command is that command is what is going to be sent the moment that the ICOM input block is executed. And then it's also going to be, I found, it's also the same command that's executed as soon as you open the ICOM monitor. I found that, and I discovered this because when I had the start command set as the turn on the channel command, I noticed that I had my output was turning on unexpectedly, and then I connected it to my monitor sends the start command every time, even though it has a manual send start here. So just a quick thing to look out for. And then options, the stop command is what the ICOM input block is going to send when the worksheet is stopped or the execution is stopped on it. For this one, since I'm just configuring, the sole purpose of this particular worksheet is to set the voltage setting, query it to validate that it is set, and then turn off. I just have the channel off as a safety here. But that brings me back to the measurement data request. This is the actual Skippy command that queries what the voltage setting is for channel 1 of my power supply. And as long as the worksheet is running, it's going to continually send this command. So to view what that output is, I have the list display, which that is under, in the modules, your display. So at bare minimum, your worksheet is going to have some sort of data input and then some sort of display module. For this, since it's just a discrete point, like my voltage setting, the list is the best option for this. And then piggybacking off of that is just like you would in a lab view diagram, you have some sort of stop mechanism. I do have, the way I stop this worksheet is whenever the value comes back from the ICOM master of 5, since I'm setting this to 5 volts, whenever I get that back, it stops the worksheet. You can have it to where it pauses or stops. That's what the measurement control in the stop button is. The stop button is actually under the control tab. And you have lots of things you can add here. This is where like all your buttons and switches and all that is. I'll show that a little bit later in the next setup that I have in this overall sequence. So let's just run this real quick so you can see what that looks like. And this will query a few times. I'm not 100% sure why it has to take a few measurements since the first measurement is always 5 volts. I don't know if that's some sort of processing delay. But as you can see, it's already stopped. It's gone back. You'll notice if it's still running, the stop button will be red and the little pause button will be blue. Now that it's not running, the play button is green again and the pause and stop are grayed out. So because this is a very like simplistic worksheet that's just a part of an overall sequence, I hadn't bothered to make a GUI for it. But if you do want to make a GUI for it, it's actually really, really simple. So under Window, you'll just do New Layout because there's not one by default. And you'll come up to this blank screen where you have options to draw your icons. You can load bitmaps as images as bitmaps, which is this guy down here. You can draw lines, rectangles, filled rectangles, circles. You can add text lines, text blocks. So the main way to relate what's in the worksheet, the diagram area of the worksheet, is you'll come to this link graph option and you'll just draw, it just draws a rectangle. You can resize this rectangle as needed. When you double click on it, it brings up the option for you to link a specific module in it. So the only module in this particular worksheet is the list. So when I add list 0, it also lets me configure the module from here, which I don't need to, I've already done that. And then I can kind of play with what it looks like. So I can add a frame, background color, I can choose my background color. So let me actually do it. Let me show you what it looks like without a frame or a background. So there I have my list. If I wanted to make the background be colored, I can add this filled rectangle here. Default color is black, but just double click on it and then fill. Let's make this, I like this blue here. Let's do that. So blue, and you'll notice it's on top, but just right click and under object order, just say move to background. And then when you click away, there's your list object has come up above it. So because this kind of blends in right now, let's double click on it, bring up the link graphic. Let's add the frame back. So that's what it looks like with the frame. But I kind of wanted to stick out a little bit more, so let's give the list icon its own background color. I want some contrast. Let's do pink. Oh, wrong OK button. So if we do pink, there you go. Kind of, you can see how that'll work. You can reposition. And then I can also add a text block. So if I add my text block here, drag and size, just gives you text. Then if I double click on it, say the voltage setting of power supply 1, and then I can change the alignment, so let's make it centered. It's also really tiny, so let's change the font size. Oh, I have different font options. I can make it italic or bold. I just want to increase the size here. Let's do 24. And let me resize this so it's all one line. Oh, it's not what I want. Yeah, single click to select on it, double click to open its settings. So there you go. That's how you create a GUI. Very fast, took 2 minutes. So I can save this, I can run it again. So hitting the run button from the layout view is the same as hitting the run button from the worksheet view. It's going to run this particular worksheet. And see, it goes, hits the stop criteria, and it's automatically stopped on its own. So that's the create a simple worksheet, create a GUI, and create some sort of stopping mechanism. So one of the other worksheets I have in this particular test setup, so I have the same thing to configure the current, configure the voltage, and then I also have, let me open up my other one. So this measure the current. So this power supply in this setup is powering on a Raspberry Pi 0W. So once I power it on, I'm continually querying the voltage, the measured voltage level of what the load is drawing, so I know when the Raspberry Pi is fully booted and the Wi-Fi is up and running. So for this particular worksheet, I've changed the start command to be the power on, or channel on command. I don't want this worksheet to turn it off again, so I have no stop command. The reset, start, and stop command are all optional. You don't have to have these. But the start and stop commands are only sent once. Start one time at the beginning, stop sent one time at the end when the worksheet is stopped. But this time, I'm going to query what the measured current is coming back. So the Skippy command changes a little bit. So instead of source, what's the measured current? And again, I'm outputting that to a list. But this time the stop condition is when I hit a parameter where the measured current is greater than 0.25 amps. Because I found out of trial and error that once the Raspberry Pi has gone above 0.25 amps for a moment, at least several measurements, it might settle back down below that, but once it goes past that threshold, that's when I know the Wi-Fi is up and running and ready for me to SSH into the Raspberry Pi. So the next worksheet I have, so both of these worksheets have been an example for just opening up a plain old socket and sending ASCII text strings to it. The other worksheet I have is talking to my Analog Discovery 3 here. So what I have for modules, so on my inputs and outputs, this time I used, under Digilent, I did AI record. So that is what this block here is. So when talking to one of the Analog Discovery, and I could do the Analog Discovery 3 or the ADP 3450, the same way that you have a drop down in waveforms, you'll have the same drop down here. So you can actually see both my Analog Discovery 3 and Analog Discovery 3 Pro show as options. The only reason I'm not using the 3450 right now is because I'm using the logic analyzer function, which, because this particular driver, the Digilent driver, is in beta form, the only thing it can do is the scope function, so just read an analog waveform in. So it's automatically selecting channel 1 of the scope on the Analog Discovery 3. I can change the input range, so the Analog Discovery 3 can do plus or minus 2.5 or 25 volts. I set the unit, I'm measuring voltage. If I had a current viewing resistor and the proper circuitry set up, I could change this to amperage. And then because there's 2 scope options, even though it defaults to scope channel 1, I could also enable channel 2, which it's 0 indexed here. So 0 is scope channel 1, 1 is scope channel 2. So you just add that by hitting this little plus button over here, and you change, like, whichever one you're currently configuring is the one in green. So that kind of throws me off. So the red one is the one I'm not currently configuring here. But the green one is the one that you're currently configuring. I'm not sure what this area is. This seems like this is blank. It's another beta quirk, but I think you'll notice that here, I think this is another quirk of it being a beta driver. The block will let you have 2 different input range settings. That's actually not possible on the Analog Discovery 3. Both channels, I believe, need to be the same input range at one time. So I'm just gonna hit cancel since I don't want to save that. But what that would do is, you notice you have one output here actually I'll just go ahead and enable it. It would just give you a second output if you had the other channel here. So if you add the other channel, hit OK. Notice you have 2 scope outputs here now. So I could hook up the second channel of the scope. So I'm reading in on the scope channel. I have a little direct digital synthesis chip that's outputting an analog sinusoid here. So I'm taking that and I'm putting it into an XY chart block. That is under modules, and then display. You have, or YT chart, not XY. So YT chart lets you plot against, it's plotting each symbol you receive sequentially. And then you can choose whether it's a time base or frequency base, based upon if you're feeding it time domain data or frequency domain data. So because I want to bring in time domain data based on time, so Y/T is for time. So that's what this, every time you add one of these modules, you get the corresponding window here. So it can make things kind of cluttered. What you can do under the view option is under all windows, you can say hide all windows, which will hide everything back. They'll still be there. So if I hit hide, it just kind of makes it to where I can see everything. But if I want to bring them back, I just go to view, all windows, show. This is also a super handy feature because I've noticed through personal experience and through a couple forums, there is a Windows 10 and up glitch where when you add a new YT chart or XY chart or any of these, it shows up off screen or super minimized or super tiny. And for the longest time I thought something was broken and couldn't find it, but if that happens, if you add one of these chart blocks and you can't, and the corresponding window doesn't automatically appear, just come to view and hit show all windows and that'll make it viewable. It'll overcome that little glitch. Again, that's another thing I expect to be fixed in the next rev of DASYLab. This is DASYLab 2024, or version 2024. I fully expect a new version to be coming out soon. So I do have the straight time domain data of the sinusoid here just so I can verify I'm actually seeing something on my scope. And then I feed it through just a plain FFT set for the amplitude spectrum, because what I want to see is where do I have the most power in my spectrum, which the most power in my spectrum is going to relate to what frequency my DDS chip is actually outputting. So because I told my DDS to output a 1 megahertz signal, I should see the highest amplitude in my frequency spectrum at 1 megahertz. So that's, and I don't have any filtering enabled just because I want to see the raw output, but you do have the option to interpolate up to ×2 or decimate by ×2, again, built into the block. Again, I'm not doing that here just because I want to see what the raw output looks like, because the whole idea of this test is just to test the fidelity of the DDS chip's output, which then I have that because I want to measure the peak in the amplitude spectrum, I'm using this FFT maximum block. So my start frequency, so I have my start frequency at 100 kilohertz because my whole spectrum, I have the sampling rate of this particular worksheet set to 2 gigahertz. I have the underlying sampling rate of my AD3, which is, so the time base is set to 5 gigahertz, which is the sampling rate of the AD3. The measurement setup sampling rate of DASYLab, so the sampling rate of this FFT block is 2 gigahertz or 2 gigasamples per second. So I have my start frequency at 100 kilohertz going all the way up to my maximum, which is, well, technically my maximum is half of that, but according to Nyquist. But I have the end frequency set to be the same sampling frequency of the worksheet. And then as it slides across, as the window of the maximum slides across that in spectrum, it's sliding across in a bandwidth of 100 hertz. Obviously, shorter I make that bandwidth, the smaller the window that's sliding across that band to look. That's going to take more processing time, more processing power, more memory, that type of thing. But if I widen that window, the sweep is shorter and it will be faster and take a little bit less power from a computing standpoint. And then the step width of how big of a step that window takes as it slides across the spectrum. So I have that set to 10 Hertz. Again, if I had those steps bigger, the sweep would end up happening faster, and it would take a little bit less computing power because it's not running as long. I think, yeah, because the maximum what it's doing is it just has a window that it's sampling as it slides across the entire spectrum you have coming out of your FFT. And what that does is it discretes individual output, or it gives you discrete points of where it finds in the spectrum the highest amplitude. So I have that going to a list display, the same type of list display I had displaying what the measured current was, just because it's an individual discrete value coming back. And this block average, I was able to, I take each individual, a running average of each of those points that the maximum returns, and I just say cumulative average for the maximum value. And then I output that maximum value to another list. That's the same as if you were looking straight on the scope manually, hitting the peak hold option. So that's a fun little hack there for DASYLab. And then, so this whole chain up here is just the raw output of my DDS chip. Because this is a very cheap little dev board, I was fully expecting some noise to come from like the onboard oscillator and other parts of the circuit. I did create another chain here through a bandpass filter. So to create a bandpass filter, I did have to do 2 filters because it was just a low pass or a high pass. So I just did a low pass followed by a high pass filter to give me my band pass. So the first filter it goes through is a low pass filter with a cutoff frequency of 1.5 megahertz. And then I put it through a second filter that is a high pass filter with a cutoff frequency before it starts allowing frequencies through of 500 kilohertz. So that gave me a bandpass filter with a 1 megahertz range around my center point of 1 megahertz. So 500 kilohertz to 1.5 megahertz. And also note, because these digital filter blocks, they are under the signal analysis tool, or the signal analysis section of modules. These do take time domain data, not frequency domain data. So these did need to come straight from the output of the Analog Discovery 3 scope, and then put them through an FFT to move the filtered output into the frequency domain for analysis. And then the same thing again, I have my my maximum chart here, seeing where the peak amplitude is in the frequency spectrum. I'm outputting it to a YT chart, so it shows me the frequency spectrum. And again, I've got my straight list of measured amplitude peaks, and then my average list, which is my equivalent of my peak hold. The other thing about this particular diagram, the way I wanted it to run is when I run this diagram, I want it to stay running until I tell it to stop. Which, of course, if I'm just running this worksheet by itself, I can hit the stop button from the worksheet. But because I wanted this to be part of a sequence, and I wanted the whole sequence to run, and not only did I want this to stay running until I shut it off, but I also wanted the sequence to pause in this worksheet until I shut it off. That's why I have the on-off switch going to a global variable. So this global variable is used by the sequence of, it has to be a global variable because, like I said, the sequence the sequence file and the worksheet file are two separate things. So there has to be a global variable for both of them to talk to. So just like in any other software application where you have different functions trying to manipulate the same variable that needs to be a global variable, it's the same concept as the global variable here. So I'm having the worksheet set the global variable to a certain value, and then that way the sequencer can take that variable and, based upon what that current variable is, perform a certain action, which is either stop the whole sequence, move on to the next worksheet, etc. So now that I've explained all the functionality, this is one that I did create. Because this is the main worksheet running in my sequence, I did create a layout already for this one. So this one looks a lot cleaner than the other one. So I kind of sectioned everything up in the main 3 areas that I talked about. So I have in my first little section just the time domain graph of the raw data coming out of the DDS into the AD3. So this is just kind of my, am I actually getting data here? And then I have my full unfiltered frequency measurements here. So the actual frequency display, the measured values, and then my peak hold measured values. Just because in this list format, it's kind of hard as they're scrolling by, and there is a little bit of jitter in my signal. It's kind of hard to see overall what the actual peak is without that peak hold function on. And then my 3 filtered frequency domain outputs, so the actual diagram or the YT chart, and then my 2 lists showing the center frequency and then the peak hold of that. And then I made my nice pretty button nice and big down here. Because the way this runs in the sequence, I do have the button, the on-off button, default to being on. So when I turn it off, I'll show in the sequence later, that's what triggers the sequence to move on. But it will stay running until I hit the off button. So now that I've kind of shown all of my individual worksheets and their individual functionalities, looking at, if I switch over to the sequencer view, because I don't have a sequence file open, it's going to show unknown. So I could start creating a new sequence here by just right-clicking on unknown, which means unnamed. So if I do new worksheet, that would then let me, it would open up the browser and let me choose a worksheet from wherever. So I have this in Digilent, DASYLab. These are all of my worksheets here. Because I already have one, I'm going to go ahead and open this existing sequence file. So I'll do open and then navigate to it. So I have my sequence file, which is .dsq. The worksheets are .dsb file extension. So I named my sequence AD9850 tester, which is the DDS chip on my little blue board over here. So I've got my sequence here. I've added my worksheets. So the configure the voltage of my power supply, my worksheet to configure the current, my worksheet to then turn on the power supply output and then measure back the current until the Raspberry Pi is drawing enough voltage to show that it's operational and ready to go. And then again, because the worksheet actually doing all the measurements of the DDS output, that's the worksheet that's open, that's why it's in bold here. But I have the next one here. So to add an action to the work, so when you first add a worksheet, there's no actions to it. So the first thing you have to do is select which worksheet you want to be the starting worksheet. It's the first worksheet launched when you hit the play button here. So like I said before, you'll do right click and say set start worksheet. You can always change this. So like if I want to do the config current, I say set start worksheet, it'll update and see now you have this little dash start next to it. So I'll set it back to my original one, and then you'll do new action to add a new action. Just to show what I have here, event is measurement stop. So because I have this worksheet configured to automatically stop when it queries the voltage setting back, if it reads back 5 volts like it should, the worksheet stops itself. So that event, measurement stop, the event of the worksheet stopping itself, that's the event that triggers the action to load and start the next worksheet. So when you choose worksheet load and start, it'll ask which worksheet you want that to be. The worksheets available in this dropdown will only be worksheets that you've already added to the sequence. You can't add new worksheets to the sequence from here. You have to make sure you add them first by right-clicking on the sequence name and saying new worksheet. So that's what I've done. Configure the voltage. Once that worksheet stops, load the next one to configure this current. Once that one stops, load it to measure the current, to turn on the channel and measure the current back. Once that one stops, it launches my tester worksheet. And then the action on this one, however, is once a value is reached of a global variable, it will stop that particular worksheet. So the measurement stop is now the action instead of the event. So when you choose reached value, you'll specify the specific global variable and that is you're looking at, and then what value that global variable needs to be to qualify as that event. One thing that did throw me off is that you have to, like, you can declare a global variable in a sequence, you can declare it in a worksheet, but if you forget to link the two and declare it overall, the two global variables, even though they're named the same thing in the worksheet and the sequencer, they won't know about each other. So to link a global variable and make it truly global across the sequence and the worksheet and everything, you'll need to go to options and define global variables. So it'll give you this option here. So number 1, it'll just index them. So number 1, you'll double click on it, give it a name, and then what default value it is. And then once you add it there, you can come back to options and say, look at the overview of it. So I have an overview, defined variables, variable 001, and then under modules, it's got the right stop, and you can see what that variable is tied to, how it's supposed to behave, where it is in sequence or actions, and all of that. So like I said, that was something I missed that took me a minute to figure out, because I was like, oh, my sequence is not working. It's because I forgot to define my global variables in DASYLab as a whole and link them between the worksheet and the sequence. So now that I've talked through everything, let's take a look and see this running. I think, let me double check. Okay, we're still good. I've got the IP address is still set, not on. So if I hit run, I didn't really change it, but fine. So opens up, setting the voltage on PS1, and notice it opens up the display I just had. Because I haven't made a GUI for that one, it didn't open up a GUI, it just opened up straight to the worksheet layout. So now it's gone through, it configured the voltage, configured the current, and now we are, it has turned on the power supply. As you can see, my power supply, the button's green, so the output's on, and it is measuring the current value that the Raspberry Pi is currently drawing. Don't know if you have a good view of it, but you can see the green light on the Raspberry Pi Zero that it's on, thinking about it, booting up. So we'll just give this a moment. And then as you can see, it opens. Oh, I forgot to add it. There's an action to have it open up into the GUI instead. So as you can see, I've got my scope running Obviously, I haven't commanded my DDS chip to output anything yet, so that's why my spectrum just looks very general. So let's SSH into the Pi real quick. So SSH with my user, Pi. Fun fact, if you don't have to try to figure out what your Raspberry Pi's assigned IP is, you can just do raspberrypi.local if you're on the same local network. And so I'm gonna run my Python script to have the DDS chip output the 1 megahertz signal, and then you'll watch. And now we have our 1 megahertz, and you can see, because it's a pretty low quality chip, or low quality, very cheap dev board, you'll notice my peak hold measurement is fairly off from 1 megahertz, although the longer it goes, the more it warms up, it eventually gets closer to the 1 megahertz output. And then this will just continue to run until I hit my off button. As you can see, you can kind of see what I meant about how like there is a little bit of jitter, so seeing exactly what the peak is equaling out to is kind of tough just on the straight amplitude measurement. So you can see where that peak measurement option is pretty necessary here. So if I hit off, that will stop this particular worksheet, and it will stop the overall sequence. You can see, again, the stop button and the pause button are now grayed out, the play button's green again, and if I go back to sequencer, same thing, and it's ready to go to run again when we're ready. Although, because I do have the Raspberry Pi script separately, I do need to shut my Raspberry Pi off and reboot it. Anyway, that is a crash course getting started with DASYLab 2024. This has really only scratched the surface of what DASYLab can do. There is a full series of getting started lectures on YouTube for DASYLab. It's a little bit dated at the moment. It's been several years since I put it out, but the GUI and where the buttons are located hasn't really changed that much at all, so like you can still learn tons from it. It goes a lot more in depth. I think there's like 9 or 10 lectures, and each one is about an hour to hour and a half long. So this video, I really wanted to give a more concise, end-to-end getting started definition or view of it. So you can get up and running with DASYLab, make some very basic things, and then once you have some more specialized questions of how to do certain things, I'll recommend going back to that lecture and kind of skimming through each to find those specific places. I'll link that lecture series down below. And also, if you have any other questions, leave those in the comments below. I'll also leave links to all the downloads for DASYLab, where to download it, the manuals, and then I have some past project stuff that if you're interested in what this setup looks like, also check out my other video highlighting this specifically. And I think that's all my ramblings for today. Thanks for watching, and I'll catch you in the next one. Bye. Oh, I'm sorry for my cat on everything. She, you know cats, they gotta be a part of everything. Okay, bye. For real.